So let's start with the first point, which is kind of a recap of SRE principles and practices. A lot of this was covered in some depth in the SRE Foundations course. Yeah, we talk about SRE as if it's kind of a singularity between Dev and Ops. In the DevOps Institute, I'm a DevOps Institute ambassador. I'm also an ambassador of some other organizations that are similar. It's often said that, SRE is kind of the new ops that goes well with DevOps. And certainly the idea is to help tie together better the practices of Dev and Ops than not having these practices. They're very deliberately intended to help break down communication silos so that information and systems and flow and products and flow better between the development in Dev and the operations and Ops. It's also other types of integrations between the application itself and the environment in which it runs. That may happen both within Dev and in production. In general, using software engineering practices together with systems engineering. SREs are dealing with large systems, multiple systems in many cases for the whole site of activities that they're responsible for, and really do that in the manner of building solutions or engineering solutions rather than just working as a sysadmin. The blue highlight is saying it's finally all about delivering business value to customers through reliable services. Yeah, so it's more than just, again, operating a system to keep it working. This is really taking a broader look at the business and how do we help as SREs to make sure the business is meeting its objectives, largely through helping the business scale reliably and engineering solutions that will make things more efficient, therefore more profitable. In general, it's all about bringing joy to the customer. SREs are usually people that are pretty much in tune with the clients and customers of the services they're supporting, and they bring that what we call wisdom of production knowledge to the whole life cycle and help development teams understand what's important to clients. Yeah, this is an interesting little exercise by itself. I don't know if you've seen diagrams like this. I believe this is actually a kind of a traffic diagram for some services that are offered by Google, and you can find other similar traffic pattern diagrams like this. Around the outside, there are different endpoints in the systems that are being used, and the links are indicating traffic going between one point or another. A lot of them seem to be coming to one point. And so that's the dark area. The darker areas indicate a larger amount of traffic. And you'll see some of the other links that are not so visible, but are there. So there's a lot of traffic going between certain nodes. So presumably those are some critical nodes in, let's say, maybe different parts of the distributed system. The point is that this is a complex looking diagram, and traditional sysops type management of systems is generally not going to be sufficient to deal with something that's complex. These modern systems are highly distributed with many types of nodes as well, some in the cloud, some not. So there are worker nodes processing jobs. There are storage and also network nodes. All of these together constitute a lot of things to manage and a lot of things to track, be aware of, and understand objectives for. It's pretty much impossible to do this unless you've got some procedures in place, some good practices in place, and tooling and automation. So this slide is really just emphasizing how important the practices of SRE are to be able to handle and manage in production such complexities. Because even though this is a Google diagram, it could equally be applied to many other systems where you've got a lot of systems involved in providing services. Just a recap of some of the SRE practices. So SREs have very broad responsibilities, keeping track of what is probably the most important of the various types of reliabilities, which is availability, to make sure systems that are needed and committed are up and running and not down. So availability is usually the most important of all the different kinds of reliabilities that SREs mostly care about. But there are others. There's different aspects of latency, response time, different forms of performance, efficiencies, and keeping track of all of these things through monitoring, um, knowing when to kick in emergency response, how to detect an emergency, how to recover from emergency, how to plan ahead for capacity of the different aspects of the service that are sensitive to, let's say, seasonal traffic loads or other reasons why the traffic loads may, fluctuate. You want to make sure that the systems can deal with those fluctuations. SREs also influence design to make sure that things are being developed, designed, and built for reliability, the various forms of reliability. And they also codify, in other words, set in place rules, which may in fact be software programs, but they may also just be, detailed procedures and playbooks to help with engagement between development and ops, and also different parts of ops, and maybe security as well. And generally speaking, SREs, understand and follow principles to make sure that systems can interact well with their environment. An application may have to work under a lot of different environments. So an environment may be different topologies of the systems, different variations of, let's say, operating systems, browsers, different versions of systems from different vendors. So there's many variables and parameters that are necessary for SREs to keep track of, monitor, and be ready to take action if things go astray, either intentionally or unintentionally. Yeah. There are, this is a representation of the various SRE practices as what I call 9 pillars. I was actually the source of this diagrams a long time ago. It's in actually one of my books, came from there originally. And if you understand these 9 pillars of practice, you pretty much do at least understand what SRE is all about, because everything's pretty much covered under these different pillars. So it's in no particular order, because all of these things are important. First of all, culture, having a culture that respects and emphasizes reliability at scale. The idea of having SREs that are really knowledgeable or wise about, wisdom is more than just knowledge. It's something, at a higher level of intellectual understanding. So to try to import that wisdom and knowledge by shifting it left to development, so that things are being developed with SRE concerns in mind. In general, operate in a continuous improvement approach. You can't necessarily get everything perfect in one jump or a higher level of maturity, but in general, you always want to be working towards higher levels of performance and improvement. So that's the culture pillar, certainly a summary of that. Toil reduction is where you're applying automation to reduce the toilsome work around non-value added activities using tooling and automation. That's covered a lot in the foundations course. The SLOs, SLIs, and SLAs is a whole pillar by itself. Just to recap, SLAs are all about the legal type terms and conditions that you offer to your or commit, in fact, to your clients for any one service. SLOs are objectives that help you ensure that you are going to meet those SLAs. So SLAs are visible externally. SLOs are more of an internal measurement in support of the SLAs as an set of objectives. And SLIs are really indicators to indicate whether or not you're meeting your SLOs or not. So this is where the measurements are put in place to help you ensure that you're You've got SLI data that can then help you determine whether you're meeting your SLOs, and hopefully if you're meeting all your SLOs, then you're satisfying your SLAs. So there's a relationship there, pretty much a dependency relationship. This may include metrics such as availability, latency, response time, error budgets is another concept. The difference between having 100% reliability, for example, which is really not realistic, but and what you're actually going to measure to, maybe it's 95%. So the difference of 100 from 95 is 5%. That's your error budget that you're allowed to work with. If you commit to 95% SLO, then you're going to manage that. Having these numbers, but in and of themselves, don't implement anything. You need a way to actually get the data, and that's where measurement systems come into play. You need to have access to the data through having systems that are observable. That's what observability is all about, to make sure you have access to the things that you want to measure, and then apply monitoring tooling and approaches to the systems, whether it's the infrastructure, the application, or even the pipelines, getting a view of what's happening partly through telemetry and instrumentation. That's what measurement's all about. Anti-fragility is a separate pillar that includes the idea of doing fire drills, chaos monkey, chaos engineering, security, automation, the idea of proactively looking for areas of your systems that are so-called fragile, that are subject to, some concerns or things that might not, if they happen, it might affect your SLOs and potentially breach your SLAs as well. So that's all about a set of practices to help avoid that. Work sharing is another set of practices that have to do with working together with development and other people to ensure that you can accomplish things. You may not have all of the skills. You may need to share with some developers certain skills to accomplish some of the things you need to accomplish. Maybe it's a toil reduction project or some particular item that you need help with. Maybe it's observability. You need development to help put some observability points in the product, things of that nature. But in general, work sharing practices are a pillar in and of themselves to be able to manage workloads for the different people in the teams, ops, dev, others, on-call work. Have some rules around that so that you manage the amount of work that you're allocated for according to the different type of work, whether it's new feature development work to help with putting in place some automation or just operating on call, or maybe in monitoring and other activities. You may have to have some rules about that, and then if you do have rules, you need to be able to monitor to see whether or not you're meeting those rules. Another whole area is in the area of deployments. Deployment of new software or releases to production is really where dev, comes face to face with ops head on, something new going into production. So both dev and ops are particularly concerned about that. And there are various strategies for doing that, different things like gradual releases, green, blue release strategies, A/B strategies, canary deployments, using automation, scripting, testing, and monitoring, and how you do that in those types of examples of deployment strategies. The eighth pillar, and again, these are not really in any particular order, but it's the eighth one we're talking about, is performance management. So this is where you're monitoring for performance, application performance management, application performance monitoring, capacity testing, auto scaling, and things of that nature fall under that pillar. And finally, incident management, which includes emergency response, keeping track of who can help serve the role as needed without getting overloaded. Things like having a 25% of your time on call, so you don't get too burned out on on-call activities, but at the same time you get to participate in on-call in order to stay up to date with what our customers' concerns, things of that nature. Doing blameless postmortems is another topic that falls under that pillar. So all of these 9 pillars have to do with, really providing capabilities and practices to support all the entire life cycle from planning through to operations and everything in between, including the DevOps components, which generally focus on continuous integration pipelines and continuous delivery and deployment pipelines, and also all the way up to ops, including planning as well. There's a link to the to this blueprint, because I find this particularly handy just to explain to somebody when they ask, hey, what is SRE? What are the SRE practices? If you don't have time to go through the 2-day course, this is a way to flash it up and walk through it quickly. Like I said, if you understand everything on this blueprint in depth, you pretty much do understand SRE.